Okay, everybody. This is the lesson for 5.6, which is solving quadratics by factoring. Excuse me. We had done most of it in class, but I want us to go over it again and make sure that we understand everything that's going on. You remember you did the pinky swear that you would watch this. Okay. All right. So we're moving in. Everything we've done so far has been dealing with quadratic expressions, and we did factoring, and we did more factoring, and we did more factoring. But now we're going to deal with equations. We cannot solve quadratic equations like we did linear equations because, remember, in a linear equation you can isolate the x. If you're given an equation in this form, you cannot isolate the x in that. There are two terms with an x and there's no way you can combine them or do anything else. So what we're going to do is use the principle of zero products. If we know that two things multiplied together equals 0, that is only true if one of them equals 0. This is where the factoring comes in. So if you have two factors multiplied together that equal 0, then you just have to find the values of the variables that make each of the factors equal to 0. Okay, so we're going to start out with them in factored form so you can see what's going on with it, and then we'll spend some time factoring. Okay, so here we have x plus 4 times x minus 3 is equal to 0. If this whole product is equal to 0, then that means either x plus 4 equals 0 or x minus 3 equals 0. So I can take this, and from the principle of zero products, I can tell you that x plus 4 is equal to 0 or x minus 3 is equal to 0. Now we know how to solve these. These are little bitty linear equations. Chances are you're not going to have to do more than two steps. To isolate the x here, I subtract 4 from both sides, and I get x equals negative 4. If x minus 3 is equal to 0, to isolate the x, I add 3 to both sides, and I get x is equal to 3. And those are my solutions. Now, we always want to check our solutions, and we're going to have to check them twice. So what we're going to do is take our original equation, and we have something plus 4 times something minus 3, and I want to know if that equals 0. I have to do it twice. One for each solution. So if I test negative 4, I put in negative 4 and negative 4. Excuse me. That gives me 0 times negative 7, and that does equal 0, so that checks. Then I test the 3. 3 plus 4, 3 minus 3 equals 0. This is 7 times 0, which is 0, so that one checks as well. You can write your solutions just like that, or you can write them in set notation. You have to use little fancy brackets and separate the solutions by a comma. Now again, I don't care, but I want to make sure that you recognize this. If you see this, that means those are the solutions. Okay, so if I have 5 times 3x minus 7 times x minus 6 equals 0, here I have 3 factors. So each one of these I have to set equal to 0. Well, 5 can never equal 0, and there's no variable in there. So the only thing I really have to look at here is the 3x minus 7 and the x minus 6. So if I have 3x minus 7 equals 0, and I'm going to move it over here a little bit, if I add 7 to both sides, I get 3x is equal to 7. And then to get the x by itself, I divide both sides by 3, and I get that x is 7/3. Here, if I have x minus 6 equals 0, I'm going to add 6 to both sides, and I get that x is equal to 6. So those are my solutions. I have to check both of them. So this is 5, 3 times something minus 7, x minus, whoops, I need a blank there, equals 0. And remember, I have to do it twice. So let's start with the 7/3. So everywhere there was an x, I replace it with 7/3. Okay. Well, this gives me 5 times 3 times 7/3 is 7. If I need a refresher on that, remember 3 over 1 times 7 over 3. That's where I get the 7. Times 7 minus 7 times 7/3 minus 6 equals 0. Now notice I don't need to go any farther than that because 7 minus 7 is 0. So 5 times 0 times anything is 0, so that checks. Now I'm going to do the 6. So this gives me a 6 here, a 6 here. I get 5 times 18 minus 7 is 11. 6 minus 6 is 0. Again, anything times 0 is 0, so that one checks as well. So my solutions are 7/3 and 0. Now notice the difference here. This factor did not have an x with it. This one does. So I have to set this factor equal to 0 and this factor equal to 0. So 9m equals 0, or 2m plus 5 is equal to 0. Well, if 9m is equal to 0, to undo the multiplication, I divide. And of course, anything divided, 0 divided by anything is 0. Here I subtract 5 from both sides. That gives me 2m is equal to negative 5. Divide both sides by 2, and I get m is negative 5 over 2. So now I have to test both of these solutions. Okay. So 9 times something times 2 times something plus 5 equals 0. I'm going to do it twice. I'm going to go ahead and write it twice while I'm thinking about it. Of course, you might want to have it up here where you can see it. Okay, so 0 and 0. Well, this gives me 9 times 0 times 5, which is equal to 0. This is 9 times negative 5 halves times 2 times negative 5 halves plus 5. Now I may want to do the same thing as I did for that last one. 2 over 1 times negative 5 over 2 becomes negative 5. So this gives me 9 times negative 5 halves times negative 5 plus 5. I want to know if that's equal to 0. Well, this is 0, so anything times 0 is 0, so both of these check. Now I know I'm going through these really quickly, but first of all, we did them in class, but also you can pause and go back over stuff as we do this. Okay, so 3p is equal to 0, or p minus 11 is equal to 0. Oh, it's dark on that side. Divide by 3 here, and I get that p is 0. Add 11 to both sides here, and I get p is 11. Okay, so now I have to check both of these. So I want to know if 3 times something minus 11 is equal to 0. I'm going to do it twice. Okay, so I'm going to put a 0 in here. So this gives me 3 times 0 times negative 11. Anything times 0 is 0, so that checks. If I put 11 in here, that gives me 3 times 11 times 0. Anything times 0 is 0, so both of those work. And again, you can put it in the form of 0, 11 in the fancy brackets. Okay, so this is the solving part of it. Now when we go to the next page, you will notice that they're not in factored forms. So you're going to have to take care of that. And we've just spent days and days and days factoring, so hopefully this will not be too terribly challenged for you. Okay, so this is how you do this. If you're just given any equation, the first thing it has to do is it has to equal 0. If it doesn't equal 0, then you have to take care of that. Then you have to factor. And then once you've factored it, do what you did on the first page. You're going to set each factor equal to 0, solve it, and then check. Okay, so if I look at this, if I'm starting out, I want to know if it's equal to 0. Yes, it is. So now I want to factor it. Okay, so if I factor it, here this is the leading coefficient is 1, which means I'm looking for two numbers whose product is 6 and whose sum is negative 5. And those two numbers are negative 2 and negative 3. So I know this factors into x minus 2 times x minus 3. And this is an equation, so make sure you put on here that it's equal to 0. Now from here, it's exactly what I did on the first page. On the first 4 examples, I set each of these equal to 0. Or x minus 3 is equal to 0. And I solve each of these. So that means I will add 2 to both sides here, and I get x is 2. Excuse me. Here I add 3 to both sides, and I get x is 3. Now when you're checking, one of the things that you have to do here is you have to check in the original equation. So if you're checking, you need to make sure that you're checking in the original equation. Okay, so that means if I go to the original equation, I have something squared minus 5 times something plus 6, and I want to know if that's equal to 0. And of course I have to do it twice for each solution. Something squared minus 5 times something plus 6 is equal to 0. All right, so 2 squared minus 5 times 2 is equal to 0. This becomes 4 minus 10 plus 6, which is in fact equal to 0. So this checks. Then I do the same thing with 3. 3 squared minus 5 times 3 plus 6, I want to know if that's equal to 0. This is 9 minus 15 plus 6 is equal to 0, which it is. So that one also checks. Okay, x squared plus x minus 12. It is not equal to 0, so I have to fix that. So I'm going to subtract 12 from both sides. And I get x squared plus x minus 12 is equal to 0. Now I have to factor. Okay, so now again my leading coefficient is 1, which means I'm looking for two numbers whose product is negative 12. and whose sum is 1, this middle coefficient. And let's see, those numbers are 4 and -3. So this means this factors into x plus 4 times x minus 3, and that's still equal to 0. Okay, so I set x plus 4 equal to 0, or x minus 3 is equal to 0. If either of those is 0, then the product is 0. Subtract 4, and I get x is equal to -4. Add 3, and I get that x is equal to 3. And now I want to check them in the original equation. So I want to know if something squared plus something is equal to 12. And I need to do that twice. So -4 squared plus -4. I want to know if that's equal to 12. -4 times -4 is 16. Plus -4 is equal to 12. So that checks. X equals 3. 3 squared plus 3 is equal to 12. 9 plus 3 is in fact equal to 12. So this one checks also. Okay. On our next example here, let me see if I can adjust that a little bit. Okay. On our next example here, notice there are only 2 terms. It's equal to 0, so we're good to go. But 2 terms. Remember, the first thing you want to look at is the greatest common factor. 4 and 10 are both even, so I know at least there is a common factor of 2. And also, each of them have an x. So 4 is equal to 2 times 2. 10 is equal to 2 times 5. So the GCF is what they have in common, is 2. So, and I also have an x. So this is going to be 2x. And when I divide by that, I get 2x plus 5 is equal to 0. So I have here that 2x is equal to 0, or 2x plus 5 is equal to 0. Here, since I'm multiplying to get rid of it, I divide. 0 divided by anything is 0. Here it's going to take 2 steps. I'm going to have to subtract 5 first. Excuse me. And I get 2x is equal to -5. And when I divide by 2, I get x is -5 over 2. Okay, so now I get to check both of them. So I want to know 4 times something squared plus 10 times something is equal to 0. So I'm going to do it twice. So I'll write it twice. Okay. All right, well, this gives us 0 plus 0, which is in fact 0, so this works. Now let's do the -5/2. And your calculator can probably help you out with this, but I'm just going to go ahead and do it manually. 5/2 times 5/2 is 25/4. So this becomes 4 times 25 over 4 plus 10, and I'm going to go ahead and put that over 1 times -5 over 2. That cancels out, so I'm left with 25 plus, and this is negative 50 over 2, which is negative 25, equals 0, so that checks as well. Okay, on the next one, the only thing that these have in common is equal to 0. The only thing these have in common is an x. So I can factor out an x, and I'm left with x minus 5 is equal to 0. Well, that was easy. So I set each factor equal to 0. So x equals 0, or x minus 5 equals 0. Well, that's done. So I have either x equals 0 or x equals 5. So I'm going to plug both of these into the equation. So my check is something squared minus 5 times something. I want to know if it's equal to 0. So let's see. 0 squared plus minus 5 times 0. 0 minus 0 is 0, so that checks. 5 squared minus 5 times 5 is 25. Minus 25, that is also equal to 0. So they both check. Okay, then the last one that we did in class, or that we did before we were so rudely interrupted, is x squared minus 100 equals 0. Okay, it's equal to 0, so I'm good to go. Now I have to think back on my patterns. I'm going to look for a greatest common factor. There's nothing in common to x squared and 100. So the only other possibility, since there are two terms, is a difference of squares. Well, we know that x squared can be written as x to the second, and 100 equals 10 to the second, and of course this still equals 0. So this factors into x plus 10 times x minus 10 is equal to 0. So I've got two factors equal to, product equal to 0, so I set each one equal to 0. So x plus 10 equals 0, or x minus 10 is equal to 0. Here I subtract 10 and I get x equals negative 10. Here I add 10 and I get x equals 10. Okay. So let's test them real quick. Back into the original equation. So I want to know something squared minus 100 is equal to 0. I want to do it twice. So let's start with negative 10. Negative 10 times negative 10 is 100. 100 minus 100 is 0, so that one checks. If I check 10, 10 times 10 is 100. Minus 100 equals 0, so that checks. And again, you can write it as negative 10 and 10. But you don't have to. Okay, so that's as far as we got in class. So these last ones, again, I'm going to go through them fairly quickly so you can stop and pause and make note of any questions that you have. All right, this is not equal to 0. So the first thing that I have to do is move the 36 over here. I do that by adding its opposite. So this becomes x squared minus 36 is equal to 0. Once again, it's two terms. There is no greatest common factor between x squared and 36, no number, no variables. So the only other possibility is going to be a difference of squares. Is it something squared minus something else squared? And the answer is yes. It's x squared and 6. So I know now this factors into x plus 6 times x minus 6 equals 0. So if x plus 6 is equal to 0, then x equals negative 6. If x minus 6 is equal to 0, then x equals 6. I'm just following along the example of the last one we did. And now, of course, I want to check it. Okay, so let's test the negative 6. Well, negative 6 squared is negative 6 times negative 6, so that gives me 36 is equal to 36, so it checks. Let's try 6. 6 squared is 36, so it also checks. And notice each time, it doesn't matter what the original form is in, that's where I have gone back to check it. Okay. All right, well, on number 11, it's just a big old mess. It's clearly not equal to 0. So what I'm going to have to do is move both the x squared and the negative 4x. So I'm going to do that by adding x squared to both sides. Oops, I'm sorry, that's subtracting. Excuse me. And adding 4x. So when I do that, that gives me 2x squared plus 14x is equal to 0. Okay, two terms that set equal to 0. There is a common factor here. These are both even numbers, and they both have an x. So I can factor this as 2x times x plus 7 is equal to 0. Okay, so now I set each of these equal to 0. So 2x is equal to 0, which tells me x is 0. X plus 7 is equal to 0, which tells me that x is negative 7. Now, the main reason I go back to the beginning to check it is because what if I made a mistake here? What if I had not caught it that I should have subtracted instead of added? Okay. If I had checked it in here, it would have been okay, but I needed to go back to the original one. Okay, so I'm going to test the 0 first. So I know I've got 3 times something squared plus 10 times something is equal to something squared minus 4 times something. Okay. So if I plug in zeros here, this gives me 0 plus 0, which is equal to 0, minus 0. So the x equals 0 checks. Let's try it with the negative 7. So 3 times something squared plus 10 times something squared minus 4 times something. I'm going to have to do a little work on this one. Okay, negative 7, negative 7, negative 7, negative 7. Okay, so this becomes 3 times 49 plus negative 70. This is 49 minus negative 28. 3 times 49 is 147. Plus a negative is the same thing as subtracting. Subtracting a negative is the same thing as adding. So 147 minus 70 is 77. And this is also 77. So that also checks. Whoops, and I'm sorry you couldn't see that. So I'll leave it up there for a second. Okay, so each one is going to be different based on the kind of problem it is and the factoring involved. Okay, I would like to suggest that you pause this and try this next one on your own, but you know, it's up to you. But I'm going to follow exactly the same thing. I am going to get equal to 0 first. That is absolutely critical. So I'm going to subtract 4x squared. I'm going to add 3. So that gives me x squared minus 5x is equal to 0. So this looked really nasty. This is doable. Here I have an x in common to both of them, so I have x times x minus 5 is equal to 0. And we've actually done this one before, so I'm not going to spend a whole lot of time on it. So x equals 0, x minus 5 equals 0, or x equals 5. But now I want to check these values back into this original equation. So it's going to take me a while to write this. Okay, so let's try the 0 first. 0, 0. So this gives me 0 minus 0 minus 3. This gives me 0 minus 3. Negative 3 equals negative 3. So this checks. I don't care what they equal, they just have to equal each other. Okay, now let's do it again with the 5. And I'll just go ahead and plug it in. Minus 5 times 5 minus 3. Does that equal 4 times 5 squared minus 3? Okay. Well, 5 times 5, or 5 squared is 25, so this is 125 minus 25 minus 3. So that's 100 minus 3, which is 97. Let's see what happens on the other side. 5 squared is 25 times 4 is 100 minus 3, which is also 97. So that checks. Okay, 2 more. All right, now I want you to put a star by these because these are real easy to forget what you're supposed to do. You have to set it equal to 0 first. You cannot solve it like this. You cannot just say that x plus 2 is 0 or x minus 7 is 0 because it's not equal to 0. So there's a lot of work involved in this one. So notice I gave you a whole bunch more space. All right, so here's what I'm going to do first. Well, these factors won't work, so I'm going to go ahead and multiply this out. So this is x times x minus 7 plus 2 times x minus 7 is equal to negative 18. X squared minus 7x plus 2x minus 14 is equal to negative 18. When I combine these two terms together, x squared minus 5x minus 14 is equal to negative 18. So now I can set it equal to 0. I can add 18 to both sides, and I end up with x squared minus 5x plus 4 is equal to 0. Now that it's equal to 0, I can factor this. Again, my leading coefficient is 0. Is 1, so I'm looking for two numbers whose product is 4 and whose sum is negative 5. And they are negative 4 and negative 1. So this factors into x minus 4 times x minus 1 equals 0. So a whole lot of work to even get to where we could start solving it. So x minus 4 equals 0, which tells me x is 4. X minus 1 equals 0, which means x is 1. Now again, I'm going to go back and plug these into the original equation and see if they work. So I'm going to start with something plus 2 times something minus 7, and I want to know if that's equal to negative 18. Okay, let's start with 4. So this becomes 6 times negative 3 is equal to negative 18. So this one checks. Okay, I'm going to do it again with the 1. Okay, so 1 plus 2, 1 minus 7. This gives me 3 times negative 6. It equals negative 18. So that checks as well. And finally, our last one here. We're going to have to follow exactly the same thing. If this was factored and equal to 0, good to go. If not, we're going to have to multiply it all out, set it equal to 0, and then factor it all again. Okay, so the left side becomes x times 5x plus 4 minus 1 times 5x plus 4, and that equals 2. 5x squared plus 4x minus 5x minus 4 equals 2. Combining my like terms, I get 5x squared minus 1x or minus x minus 4 equals 2. So now I need to get it equal to 0, so I'm going to subtract 2 from both sides, and that gives me 5x squared minus x minus 6 is equal to 0. Now, since I have a leading coefficient here, I have to multiply this. I'm going to have to split and group this one. So I'm looking for two numbers whose product is negative 30 and whose sum is negative 1. Did I do that right? Okay. It is negative 6 and a positive 5. So what do I do with that? I'm going to split these. So this becomes 5x squared minus 6x plus 5x minus 6 equals 0. So now I can group them. GCF here is x times 5x minus 6. GCF here is 1 minus 6 equals 0. Now I have a common binomial factor of 5x minus 6 times x plus 1. Now I can set the factors equal to 0. So 5x minus 6 is equal to 0. Add 6 to both sides. That gives me 5x is 6. Divide by 5, and x is 6 over 5. x plus 1 is equal to 0, so x is negative 1. And since this is the very last problem, we're not going to check it. You can check it on your own. Okay. Believe it or not, well, you will believe this. I made a mistake earlier when I did this and found it in the check. So, you can definitely do that. All right, guys, that's the end of that, and I will see you next week.